Okie doke. So, today is a continuation of the last time, and hopefully, I'm not sure, but I think we'll finish the program today. We're going to go over the last 4 steps in the program that we need to finish, and that's what those are. To remind you, when we design and write programs, we start writing by breaking the problem statement into a few simple steps. A few, like 5, no more. Try to keep it simple. And then you break those steps into sub-steps. Each one of them you break into 5 steps if necessary, or less. And you just keep doing that till you think you know how to do everything. Then you start with the lowest level, easiest, hopefully easiest, but perhaps one that you're most unsure about. You get that one to work and then work your way back up. And you test each piece as you do it. That way you know that the code that you write next can depend on it to be working. Otherwise, you'll never, ever get it to work. You got to get little pieces to work, because that's all I'm afraid of. Little pieces. Even though I've got 500,000 lines of code in this thing I'm writing at home. Little pieces.
You won't know where in that it is.
Exactly.
The problem.
You know, something goes wrong, it could be anywhere. Don't go crazy. So you continue coding.
14?
Day 14, yes. So you just keep coding up until you're all done. And so let's remind ourselves where we are in the design for this program. So we've done this step here, step 2.2, but we haven't done anything else. It seems like a lot, but each one of these is teeny. So, and that's the whole idea. Each one's teeny, easy to do, and away you go. So, let's do the 4 steps that basically are left. We're going to read from a file, because right now we're reading from a string. Remember, we set a string to be Leland blah blah blah, and we did all our processing so far in that string. So instead we're going to read that from a file. Once we figure that out, then we're going to loop over all lines in the file. Once we figure that out, then we're going to add calculating the cost. The whole thing's about how much does it cost to make all these prints and copies and stuff. And then printing the results out. So, in a previous program, not too long ago actually, just two lessons ago, we used a function called fget to read a line of text from a file. And we did this. And fget is abbreviation as usual for file get string, which of course is obvious. So you just have to get to know this after a while. So file get string. So in this case, we're reading from the command line, which C calls the standard input, and of course abbreviates it as standard in. Then we're reading it into a variable named input string, which we defined somewhere else. I'm not showing that here. And at most 99 characters, because we made input string to 100 characters. What we did 2 times ago, that will work just fine for today. So we'll just use that. And so instead of, right here, we had string copy, input string, Leland, blah, blah, blah. Now, we're just going to read it from standard in. So this is the only change we're going to have to make to our program that we already have. So, go to day 14, create it, go there, and then we're going to copy test 1 from the last time, day 13, to here. That's what that dot means. And then we're going to edit that file. Don't forget the end. So tell me when you're up to here, and I'll go back to what line you need to add. So, if you'd like, I can translate this. We're copying a file from one directory up, then directory day 13, then file test1.c, and we're copying it to this directory. Dot is this directory.
Okay, what?
And that'll take a while to get in your head. So double dot is back up one directory. Then day 13 is the directory that we already created last time that has a file named test1.c. So double dot backs up, then it goes into day 13, then it goes down to test1.c, and then it copies that to this directory, which is dot. And again, all these dots, dots, again, it's just like strcpy. It's a simple abbreviation for programmers that can't type.
Okay, that doesn't look like me, because I'm not supposed to be actually typing that.
You type all this, yeah.
Okay, so
Yeah,
whatever
you're
it is,
typing
it
that.
But I'm not.
Didn't work?
I'm not.
Let's see. No such file directory.
But that was,
All right.
but, so here's where I typed it.
All right, let's make sure we know where we are. pwd, we're in day 14. Okay, so it doesn't seem to know that there's a day 13. Let's see what's in day 13. We've got a test1.c. Oh no, so that one actually worked. This one didn't work because you're already in day 14.
Right.
So this works. Yeah, that works.
Oh, okay.
So if you ls, there it is.
Okay.
So just Emacs it.
Okay.
Emacs test1.c and. So is it up? You've got yours up?
Mm-hmm.
Okay. So as you can see, it's got this line in it where I do the string copy
Mm-hmm.
for Leland.
Yeah.
So
take that
replace that with this.
out. Okay.
Now we're going to read it from standard in instead of hard coding it inside our file. That's all we're going to do, just replace it.
Okay.
And then
There.
one last thing
Mm-hmm.
is we need to have a file now that has this Leland bunch of stuff in it. So save this file
Mm-hmm.
and then Emacs a different one. Let's call it test1_input.csv. And this is a standard thing we do too. We're constantly creating test files. Test strings, test files, test whatever, to make sure our code is working before we try it on the real stuff. So just shove that in there, save it, and you can quit that Emacs if you want. That's a whole other one that you don't really need to have up. So that's done. Done.
Okay.
Yep.
Okie doke. So, try it. Compile it and run it. Now, running it's going to be a little bit different than what you're used to. So when you're done compiling, let me explain this. Error. Input string. Oops, you forgot the I.
Okay.
Put the I in there.
Try and
So,
In
let's
here?
see. Input string. It should be string.
Okay.
Let's save it and compile it again. Here's compile.
Well, I want to make sure I'm doing when I did the Leland, it's in this, my new Emacs, right?
Yeah.
Under test one.
Yes,
Okay,
that's
so I can
right.
save that.
That's right. You can save
Okay.
that,
All right.
and you can
Okay,
kill
yeah,
it if
I can
you
do
want.
that.
Doesn't matter. Yep.
Okay.
I just
Okay,
think it's way too
compile.
simple.
Okay. Yeah. I mean, it is simple. That's why I picked this. I designed this to be simple, real but simple. Okay. So the next line is kind of strange. We've never had this symbol in here before. So what this means is that instead of reading what we're typing as input to this file, to this program, it should read from this file instead. That's what that little less than sign means. And it's not, of course, supposed to be thought of as a less than sign. It's supposed to be kind of like a funnel, and it's taking stuff and it's funneling it into our program instead of us typing stuff in. So that's the basic idea behind this crazy symbol here.
Put it in, so the CSV is because we
Well,
named
this is the file we created,
Okay.
and we named it CSV because it's a CSV file, so it's always good to give it a nice ending. Just like in Windows, all these things have endings that kind of say what they are some way. And so that's what that is. So try running it, see what happens.
My input string is undeclared.
Uh-oh. We didn't compile input string. Okay. Input string is declared with an underscore here, and is missing one there. Alright, save, recompile, work. No, I forgot. Dot slash, that's one. Sorry, I forgot about that. There needs to be a dot and slash right here.
Gotcha.
I forgot about that. Sorry.
We should have known.
A forward slash.
A forward slash. Yeah, I don't know what would happen if you did backslash. I might try to see.
No thanks.
It won't flow up.
And it says the data.
The data, yes, the data, Leland, yes. Okay, so it still prints out just like it did last time. So that's good. So it works.
Yeah.
So we made one simple change, and it still works the way it used to. Good. Now we can go to the next step. Now, this is a little more complicated, but I will explain it to you, and you'll just have to trust me until you get better at all this stuff. There's some jargon on the web. So basically, if you use the browser to search for FGETs, you'll go to this site that we went to last time. It gives you all this explanation as to how to use FGETs. And one part of that explanation is telling you what the return value is. So whenever you use any of these functions that C gives you, like string copy and all this stuff, there's what it does and then there's what it returns, just like our function. And so you always go and you look up how the thing works so that you make sure you use it right. One of the things about FGETs that we didn't just use is that it has a return value. So we used it just to get that string into that string variable that we had. We didn't care what the return value was. So we didn't even do anything with it. We just kind of ignored it. It turns out that FGETs is made so that if you hit end of file, it will return a null value, basically 0. And if it reads something successfully, instead of returning null, it'll be something that isn't null, which sounds just like what you need inside an if for a while in order to decide if you want to keep going or not. And that's what we're going to use it for. If we put it inside of a while, which is just like an if, but it just keeps repeating, as long as what's inside is true. So true means non-zero. So as long as FGETs returns something that isn't null, it'll keep looping. And this is where that looping stuff comes in. So while is our looping thing. And it just keeps looping over and over and over again, as long as FGETs returns something that isn't 0, that isn't null. The moment FGETs returns null, this loop stops and it goes on with the rest of the program. So this is exactly what we need to read every line in a file when we don't know how many lines there are. This will just automatically tell us, I hit the end of the file, we're done. And so a quick change to our program will just add this while stuff. And now the thing will work for any number of lines in a file instead of just one, which is what our current version does. So, all you have to do to your current program, which hopefully is still up there, is to change that line to be this while around it with the curly brace, and then an end while down here, right at the end of your program. Everything else inside there you want to do for every line in the file. So all that stuff gets done over and over and over again, including printing. So make this change, compile and run, compile, see if it works, and then we'll change our input file so it has more than one line. Yeah. Almost. That should be a begin curly brace. The line up there.
But not the...
Yeah, those are the while. Almost. Okay, now you still need, you deleted a paren and then paren.
Oh, geez.
So one paren ends your fgets and the other paren ends the while thing. So you need two paren.
Yeah.
Yeah. And then while, that looks good.
Okay.
It compiles, good.
Okay.
Okay, see if it compiles. Test one. Test one.c. That's test one. Come on. .c. You don't need an and. Alright, we both compile. So, in order to test this out nicely, we need an input file that has more than one line. So, while you're at it, just add these two lines to your test1 input.cse, or something like them. And I tried to make it slightly relevant. So it's got us in there. And programmers usually do silly stuff like this.
I just had one in here. I couldn't find it. I saved it because I knew we were going to need it. Huh.
Well, just start at the
How do
Emacs
I
again.
find it in there?
If you want, see it's right there. You
Okay.
can actually just
Up there?
mouse down,
Uh-huh.
mouse up, and middle button, and hit return. And if you want, you can leave it up, but I don't think we're going to do anything more to it. I think this is it. So,
Okay.
whatever you want. You can grab this right off the PDF and paste it in if you want. Because I think that works. So you don't really have to get good at typing this crap. You do have to get good at typing C though. Motor memory, brain memory, all kinds of memory. Get that C in your head. But yeah, we don't
We
need
see how
CSV.
cautious we are about our little things. I'm like, okay, I did something wrong.
See?
Underscore input. Nah, that won't work. The command line is somewhat pathetic in that way. You can't really edit it when you edit a file. Dot slash again. Dot slash test one. Okay. There you go.
I don't know why. This way. I mean, I'm
People
looking
get
at an
used to
underscore
stuff.
and I put it down.
Yeah, people get used to stuff, that's for sure.
Okay.
And yeah, you can just run it again by running it as you ran it before. So if you see that right there, either you can go up like this
Okay.
and find it, and then
Okay.
just hit return.
Okay. Cool.
And okay, so did you get rid of Leland? You got rid of Leland, didn't
Yeah.
you?
Oh,
And that's okay.
Oh,
I don't see what in
extra.
there.